All right, folks, it's 9 o'clock. At least my computer tells me it is. It's top of the hour, so let's get this party started. This is the MLS working group. Sorry, I'm just switching rooms here real quick. All right, so it's my first time running Meet Echo here, so hopefully you'll bear with me. Hopefully I won't screw anything up too badly. It seems like some people have done some sessions though, and there's some help online, so in case I do anything wrong, you can correct me. All right. So this session is actually being recorded. I don't know that we so much need to share video. I'm going to run most of the slides. If you need audio, you can request, and I'll let you in. There's particulars. This is the know well. Again, we're recording the session. Mind your P's and Q's. If you have any IPR that you know about, you need to disclose it. That kind of thing. If you have any questions, feel free to ask. This is obviously this MLS session. The agenda is kind of light. Richard did send me a bunch of slides though, so it'll be fun. So we're going to go through just some administrative stuff. The virtual blue sheets are automatic, luckily, but I do need a note taker. Is there somebody willing to volunteer? Is that you, Joe, agreeing to say?
Yeah, that's me.
Excellent, thank you. Okay, that worked out better. We don't often use the Jabber, but hopefully someone's watching the chat. So if anybody says anything in the chat, then feel free to kind of jump in. Maybe we can group do this. I'll do a bit of a status. The primary motivation of this session is going to be maybe a little different than some of the other sessions, and that we only have 50 minutes, and the idea was to go through the any outstanding issues and pull requests on the protocol draft. We'll give a real quick update on the other drafts. So we have three drafts. One's expired. The Federation draft is expired. I suspect that after we get the protocol locked down a little bit more, it'll come back. And Benjamin did post a new version of the architecture draft that not only just bumped it, but included some other things. But he's going to put a lot more effort into the next version, which is hopefully going to come out in September or October. That's again after the protocol draft is kind of like calmed down and is more in a more final state. And that's really it. So again, our agenda is kind of light. Basically our plan is to go through some slides that Richard put together to provide some history about what's changed and stuff, and then jump right into the protocol. So unless there's any agenda passage requests. Hearing none, let's go to it. All right, Richard, just tell me when you want me to advance the slides.
Sure. I'm going to apply for video here in case people want to see feel entertained by seeing whoever it is that's talking to them. So I think I hit the, okay, so I hit the apply for video and you can grant me.
And I granted
permissions display, yeah, multi-phase commit. Wouldn't want people unintentionally sending video. All right, so yeah, Sean, I'm going to object to your characterization of this as a light agenda. We have substantive issues to talk about here.
It's only one topic. That's what I meant. Go ahead. Sorry.
So we've been making a lot of progress on this draft on the protocol through a series of virtual interims. So I wanted to, but I think we've got a crowd here at the IETF meeting is a little bit disjoint from the folks who've been paying deep attention. So I wanted to provide a little bit of background for what's been going on since the last time we had an kind of IETF crowd-oriented meeting, and then I've got a kind of summary of the way forward to get this to last call and ultimately to RFC. So you want to skip forward to 2 slides on with the avatars there. So just like high-level summaries, since we last talked about this, I think the last IETF-oriented discussion, I don't think we met at 107. But I kind of chose draft 9, this kind of the last milestone. Pulled the stats out of GitHub. We've merged 32 pull requests and had 8 different virtual interims to discuss them. So I think we've had a pretty good cadence of, getting things discussed and getting them merged. It kind of is a good complement to the mailing list discussion. Always pleased to see new contributors showing up here, substantive contributions from all these folks. So hopefully we'll get some more contributions from folks. So please view this as an encouragement. You'll get some recognition if you send us a PR. Next slide, please. These are the 32 PRs that have been merged. There's a lot of stuff that's in here that's in more editorial, more minor technical fixes to things like struct definitions to make them actually parse. I've highlighted a couple things in here that you can barely see in the bold, but I'm going to talk about them in the next couple slides just to give you a sense for the more major changes that are going on here. I think one of the things I'll emphasize in a bit is that the overall shape of the protocol has not really changed in terms of proposals and commits and the order in which they need to get sent. So that's kind of a good sign of stabilization getting toward the end here. Next slide, please. So one of the major things we've changed here is that we've started relying more on this HPKE construct. So when we started up the HPKE draft in CFRG, it was fairly straightforward. It was just a way to encrypt to a public key, but it became increasingly clear as we developed that draft that it was going to need to define a kind of a next layer down of primitives. So there are interface level, at least, definitions in the HPKE draft of what a KDF looks like or what an AEAD primitive looks like. And even more lately, we've imported derived key pair down there because that's the layer at which the chems are talking about, or that's the layer kind of that knows about the details of a chem. So the details of how you use X509 for HPKE. It seemed to make sense to have the derived key pair logic down at that level as well, so that MLS wouldn't have to talk at all about the internals of the chems it was using for HPKE. So basically all of the primitives that MLS relies on are now drawn from HPKE, either directly, HPKE itself, or indirectly kind of calling through to some of those primitives that HPKE defines. So the AEAD functions we use, the KDFs, etc. The only thing that's not provided by HPKE in that way is the signature algorithms, which we are leaning on TLS for the identifiers and definitions there. So we end up with this table like we show on the slide. That's a table in the IANA considerations that got added since draft 09, which just lays out for each cipher suite, the left-hand column is a cipher suite. It identifies which of the chems, KDFs, AEADs we're using with HPKE, and the signature scheme using the TLS identifiers. I'm happy to take clarifying questions, by the way, as we go along here, or not clarifying questions, because I think we're pretty relaxed on time here, so we can have a spontaneous session. All right. So the other two changes I'll highlight are efficiency-oriented. Quoted myself here. Back when we were discussing doing proposals and commits, if you think back to mid last year, about a year ago, we were still in this framework where we had separate add, update, remove messages. And in late 2019, we landed this PR that switched us over to this proposal commit framework, which is simpler in a lot of ways. But one of the impacts was that we had a constant time add operation, which the proposal commit framework turned into one that was log n. The big O notation is not quite accurate here. It was log n in the good case, but it could degrade down to linear. So as I think Raphael and I in particular were looking at some applications here and looking at how this scales up to some large groups, this seemed like it was actually an issue, this scaling out to log n. Now, when we were considering this, the proposal commit PR, and noting that ads got less performant, the discussion there noted that you could, in principle, go back and special case commits that only had ads and get their performance back to constant time, basically by not ratcheting the group forward, not doing an asymmetric ratchet forward, only hash ratcheting forward, which is how we got the performance benefit. So this PR just took that that principle and implemented it. So we said that in the so syntactically in the commit, the path which chems new entropy to the group, the path is now optional. And what that means is that it's optional when you have adds only. And what that means is that when you have adds, we only have adds in a commit, you ratchet the group forward just by hashing the epoch secret and not incorporating any new entropy. And then for anything else, if you have updates or removes, or if you don't have any proposals at all, you need to provide a path and chem some new entropy to the group, and that entropy gets folded into the key schedule. The main kind of interesting impact of this beyond the performance impacts is that you don't get post-compromise security with regard to the sender of the commit if you're doing an add-on, if there's no path in the commit. If you're doing an add-only commit that has these good performance properties. So that the security, it used to be that, you know, whenever you got a commit, you got PCS with regard to the sender of that commit. So we've walked that back a bit here. You still get forward security with regard to the new members in the sense that they can't access the group's communications before they joined, which is, you know, an important property. But you don't get this additional property that you got as an effect of the commit. So I think that's something we'll need to be clear about in the security considerations in articulating what guarantees the protocol provides. But I think the impression was that was not a critical property to lose. Next slide. The other kind of efficiency change we made was to make the tree optional in the group info, which is ultimately carried in the welcome message. The idea here is that when you add someone to the group, they need to find out the tree so that they can, you know, generate MLS messages, and also so that they can consume messages. So in the commit structure we have right now, in order to process that commit and interpret the direct path that's there, you need to know the whole structure of the tree. And so you need to know the tree before you can process a commit. When we made the commit welcome changes, we just put the tree in the welcome message as part of this encrypted group info object. Again, when you look at large groups, though, this becomes one of the bottlenecks because the tree grows at, you know, the order of a couple hundred bytes per participant. So if you've got a group that has, you know, 1,000 participants, you're talking about hundreds of kilobytes per of tree data, which gets tough to carry around because you know, because the welcome message is sent by a member of the group, this means you have to both upload, you know, in addition to the new member downloading it, you have to, the person who's sending the welcome has to upload that to the delivery service so it can be sent. So the observation here is that the tree is, you know, big, it's heavy to upload it. And if you're not encrypting your proposals and commits, it's possible for the delivery service to observe those and keep track of the tree itself. Or, you know, at the very least, it can cache copies of the tree that are sent to it some other way. Right, so you can have the delivery service cache that so you don't need to upload it. So the welcome message that is sent by a member of the group can just have a commitment to the tree hash on the right side of this diff. And instead of uploading the tree from the member in the group, the delivery service can just provide that alongside the welcome. The main trade-off here is that there's it introduces a bit of ordering dependency in terms of how you do the processing. The welcome message can't be authenticated unless you have the tree, because you draw the authentication credentials that are used to verify the key and the credential that is used to verify the welcome message from the tree itself. So you need to have the tree in hand before you process the welcome message. But the feeling so far is that that was a tolerable constraint, that you were, you know, even if you were getting the tree from not the same source as the welcome, if it was getting sent alongside the welcome, you were probably getting it about the same time. And so this ordering dependency wasn't wasn't a big deal. So that's the last of the kind of updates I've got from kind of how we've gotten here. Any questions or comments so far on kind of where we gotten to? So, all right, so I wanted to talk a little bit about the timeline for getting this thing finished, since it seems like we're kind of in view of the finish line. As I mentioned above, if you look at the PRs we've landed in the last few months, we've kind of slowed down in terms of major changes to the protocol. If you think back a year or more, like we were making some pretty big changes with proposals and commits, how you do adds and removes, and all of that has been stable for, I don't know, at least 9 months or so, 6 or 9 months. So, and we've been, making efficiency improvements. We've been, making some updates to the key schedule. But that major thing about how we, the overall framework for how we do changes, updates to the group, and how we tie things together is pretty stable. So the idea is like, let's start looking at how we tie down our last few issues and get finished here. Next slide, please. So this is my cartoon of the glide path to landing at RFC. So the things in Courier are the formal steps in the IETF process, for those who might not be so familiar with them. And then the marker changes are the things that we need to do that are special to MLS. So I've got a, in the remainder of this deck, I've got a list of kind of the remaining open issues we've got, which broadly bucket into some protocol changes and some non-protocol stuff, which is how we explain what we're doing here and make it clear and make it obvious what the properties are. So we've got a last couple buckets of issues to get done, but it's kind of almost literally a handful. I think we've got kind of 5-ish top-level technical protocol changes, and then a couple of non-protocol things that are mainly just looking through the document, making sure it has a comprehensible structure, making sure the security considerations are right. But I think all told, that comes out to a set of work that we can probably get done in the next month or so, so that in August sometime, with the help of a couple more virtual interims to come to consensus on things, we can probably issue draft 10. And I think at that point, I would propose we're probably ready for working group last call. One reason to have last call at that point is because at that point, we will have addressed all the known issues with the protocol. Hopefully we'll nail down all the pros issues. And that will be a good point to kind of declare, back I think at draft 7 a little while ago, we declared an analysis ready draft and got a lot of good findings from some formal verification work done on that. And I think before we start sending this off for IETF last call and all that last process churning, it would be good to do another one of those analysis ready drafts and get some formal verification and also some interop testing done. I think the main question here is how long we want to leave that open between working group last call and submitting this for IETF last call and IESG evaluation. Sean, can you remind us what the process was that TLS-13 went through here? Because I think they did some analogous stuff.
We paused basically for 6 months or a little bit longer, depending upon what kind of review we actually got. So as we started to get review, we kind of paused. So it kind of depends. I mean, the formal verification doesn't just happen because people, like us. They do it because they're writing papers and getting stuff out of it. So we have to make sure we line up somehow with something to be able to get them to get stuff that's published and looked at. Mm-hmm. I'm thinking we could probably figure that out, though. I'm thinking it's got to be 6 months.
So, reading that a little optimistically, we'd be looking at kind of year end for IESG review, if we were in a little bit in advance of that 6 months.
Yeah, because I don't think we could send the protocol forward without the architecture document. If the architecture document is going to get updated with all of its, if you pick A, B, and C, you get these properties, and if you pick A, B, C, and D, you get these other ones. Without at least those two going forward together, like I don't think we would not get through the ISG gauntlet. So I think that's probably realistic. As the formal verification goes on, the architecture document itself kind of gets edited up.
Yeah, and I think an important point is that, you know, modulo any findings from the formal verification, the protocol itself will be pretty stable and kind of frozen. So people can start writing code to it and start looking at integrations with applications. So that's
We've
kind
had,
of well, sort of. Sorry, go ahead.
I was going to say, well, we've had some people involved, and they haven't been screaming and being like, "Oh my gosh, no, that's the worst thing ever." So there is some confidence there. It's not maybe not as high as it needs to be, but yeah.
Yeah. No, it's not totally unvalidated. In fact, like I said a moment ago, we've already done a round of analysis on draft 7 and got some good findings out of that, and folded those back into draft 8 and draft 9. All right, so with that in mind, just want to put that kind of timeline in front of people to set some expectations. Wanted to run through what I believe are the last remaining issues, and I've cut these into 2 slides, and tried to kind of bin things together to consolidate discussion. So on this first slide here are the protocol issues, technical issues, things that are going to require protocol changes. The second slide is more editorial stuff, although that may, as we discussed, it may turn out to have some protocol impacts. Some
Just
of
to
these
stop
will
you
be
there,
familiar. Oh yeah.
I see that Brendan is here because I know that he specifically wanted to talk about 326. So we'll make sure we don't gloss over that one too quickly.
Oh yeah, absolutely. So I've gotten, so for each of the major bullets here, I've got slides to follow. So yeah, so just to remind people briefly what these are all about, if you can go back up, yeah. Protocol PR 362, which is I think the smaller change, and aspects of 336, which is a bigger bucket of changes. There are a couple of gaps between how the key schedule works and how it should work. 302 is and 360, the PR that addresses it, are about simplifying the encryption of sender data. 349 is about reducing the amount of metadata that is leaked by the encrypted objects we send around. And then there's kind of a bucket of changes around how we negotiate, how we do PSKs, and in a related vein, session resumption. And I think the last bullet there, 374, should probably be pulled out as a separate top-level item, which is having some things derived off the key schedule that people can use to authenticate the session, independent of the credentials displayed in the session. Next slide. So these are a couple of new slash more editorial issues. 160 is obviously a low number, so it's been kicking around for a while. Benjamin Verdouche has the action to flesh that out a little bit. The idea here is to provide some mechanisms in this protocol to address the risk that the delivery service might drop some messages, and so we want to enable the participants in a group to recognize when there are missing messages within an epoch. 373 was just filed, I think, yesterday or the day before. There's been this question for a while that the observation that malicious insiders can send malformed commits in a couple ways. The person who filed 373, who is unfamiliar to me, claims that they have some ideas about addressing that DOS, so there may be something to do there. And then there's a couple of issues that are just around, either clarity or adding some recommendations for how things work. So this covers all of the issues that are currently open, and the ... anything else at the bottom is my explicit invitation for folks to get anything else filed if if they have ideas, if they have issues that need to get fixed in the protocol, because we are closing in. And the other, I'll pause briefly here in case folks have things in mind that they'd like to bring up in real time here. Okay, so like I think the remainder of the time here, so we have, I guess, 26 minutes or so left. Remainder of the time, I had some slides for issue discussion, but if Brendan had an issue he wanted to discuss in particular, we can start with that one. These slides are in an order, but it doesn't really matter. Sean, which one did you say that Brendan was keen on?
It's 326.
Okay, so 326 is authenticating that added members know the PSK.
Mm-hmm.
So I think if you go to, yeah, slide 14 there, like you got.
That one. Okay.
Yeah. So in the current key schedule, we have a couple of disconnects. So we sort of added this PSK mechanism without thinking about it quite hard enough. We shimmed it into the key schedule and didn't specify how you negotiate it, and apparently didn't think about who gets it when. In particular, when you add a PSK in an epoch, it's added at a point in the key schedule before the secret you send to the new joiners. So there's actually no authentication that the new joiner knows the PSK. So it leaves it kind of incomplete. Another thing that Raphael had observed from an implementation point of view as challenging is that the group context object is shoved in a bunch of specific places. It would be slightly nicer from an implementation point of view to just hash that in, KDF that into one point in the key schedule, and then have that kind of transitively apply for the things that are derived from the thing that includes the group context. So I've got a PR here, I think it's 362, that does kind of the minimal change to address these problems. It reorders things so that the joiner has to use the PSK to get the epoch secret, which thus authenticates that the new joiner has the PSK. And then it promotes the group context from derived secret up into the main key schedule. So in pictorial terms on the next slide. Next slide, please, Sean. So that diagonal arrow, the welcome secret is the thing that gets sent to, the joiner secret. On the left-hand side, what gets sent to the new joiner is the epoch secret, and on the right-hand side, the joiner secret gets sent to the joiner, because that's the thing you derive the welcome secret from that decrypts the group info. Right, so you can see on the left-hand side, the epoch secret that is sent to the new joiner already includes the PSK. So the new joiner doesn't have to know the PSK in order to compute the epoch secret. On the right-hand side, you send the joiner secret so that they have to add the PSK in order to get the epoch secret. The vertical arrow there just indicates that the epoch secret now KDF's in the group context. Would be happy to have a review. I feel a little bit weird shoving the group context there. It feels right because on the one hand, it feels right because it just feels like it should go into the epoch secret because it's confirming the group context. On the other hand, it's unlike the other things we're injecting in that way because it's not it doesn't have the shape of a symmetric secret. It's more metadata about the group. So it's unlike the commit secret of the PSK. So that's the intro discussion I had for that. I don't know if Brendan wanted to bring up any concerns about this or questions. Personally, I wrote the PR, so I think it's pretty good. I think my main question is around how exactly that group context folds in.
All right, Brendan. Yep, you're there.
Hello. This sounds good to me. Actually, the PR that I wanted to talk about was 360.
Oh, okay.
Yeah, but we can go in order, so you don't have to worry about that.
Bet.
nobody else has concerns here, we can declare this good.
Will do.
I don't know. I'm just looking through the participant list. You might have thoughts on this. Call people out. I don't know. Jonathan Hoyland, do you have thoughts on like using HKDF extract this way? Oh, and I'll note also in light of the HPKE dependency here that this PR actually needs to get rebased on some newer stuff because HKDF extract has been replaced with generic calls to extract on whatever KDF we have. Jonathan, do you have any thoughts on using the KDF in this way? This is kind of broadly borrowing some of the ideas from TLS in terms of importing entropy into the key schedule. So I'd like to be congruent with that.
Nope, I think we're moving on.
All right. So I'm going to consider this one ready to go, I guess. Sean, does that make sense to you as chair? Go ahead and merge this one,
Yeah.
and we can solicit review on the exact scheme and fix it if we need to. All right. So Brendan, I've got a couple slides here to tee this up. I'm happy to introduce the topic and then let you, or if you'd like to.
You can introduce it.
Okay. So there's been an issue outstanding for a while, 302, which talks about using masking for sender data. This was inspired by Quick, which uses a masking technique, not AEAD, to encrypt packet numbers, which are used for forming nonces in Quick packet encryption. The nice thing about that is that it's kind of zero overhead. You KDF some, you sample some ciphertext from the encrypted content, you feed it into a KDF, you get some data that you XOR with the thing you're masking. So it's nice in that it's low overhead. It doesn't add an authentication tag or an explicit nonce. Since we started talking about this, actually, there was some academic work published that did some good security analysis and proved this has the properties you'd expect. The one thing it doesn't have is authentication. So the authentication properties you get out of it are a little bit more subtle than using an AEAD for this. And in particular, there's a bit of a difference between what Quick is doing with this mask data and what we would be doing. So the data we would be masking in this way are not purely about nonce formation, it's also about key selection. So there is a concern that, given that there's the authentication you get here is, given the masking constructs available, an attacker could kind of change some bits in the data we would be masking and thus cause folks to encrypt with an incorrect key, which seemed like a downside. So I think there was pretty good consensus to not do the Quick approach directly because of this additional key selection dimension. Brendan submitted 360, which is an interesting second attempt. It still uses AEAD for the sender data, so you get the good authentication properties. But instead of using an explicit nonce, it samples the nonce out of ciphertext. And Brendan, I apologize if I'm misattributing some stuff here. So what I'm discussing here is kind of my spin on Brendan's PR. So I admit I'm taking Brendan's idea and riffing on it a little bit because the idea of the PR is a bit different from this. So in Brendan's proposal, there's a second AEAD that covers the mask data and the content. In this variant, we still just AEAD the sender data and use the ciphertext for the nonce. Seems simpler to me, but we'll discuss that in a second. Anyways, in pictures, the next couple of slides, this is how MLS ciphertext encryption works now. Right now, you first encrypt the sender data, using an explicit nonce, and then you take that encrypted sender data and it becomes AEAD into the content encryption. So it's kind of straightforward. You work your way from top to bottom in the packet. Next slide. So for this scheme, this sampling the nonce out of the content to work, you would need to kind of reverse things. So you would need to encrypt the content first before you encrypt the sender data. And I've mislabeled the second row there should have the plain text sender and generation. So you need to encrypt the content first so that you can then sample a nonce out of it that you use to encrypt the sender data. So there's a bit more complexity here in terms of how exactly you arrange the AAD, the additional authenticated data that goes into each encryption, and the ordering in that you need to encrypt the content first and then the sender data. But what this saves you is there's no longer an explicit nonce, which means you have more rigidity, you have shorter packets. So that's the setup I had. Brendan, what were your thoughts here?
So I just wanted to say that basically the issue with the quick approach and also with this academic paper that got published by Bel Air is they assume that when you receive a ciphertext from the network that you immediately know what key it's encrypted under. So if you get a ciphertext, there's no question about what key it's encrypted under, and you try to decrypt it and it works or it doesn't. With MLS, our situation is slightly different because we encrypt ciphertexts with different keys depending on who sent it. So that's the solution to sort of work around that is we basically flipped it around. So instead of masking the sender data, we are properly encrypting the sender data with an AED, and we're masking the ciphertext in the sense that we have a non-authenticated encryption. There's the thing that's not shown in this slide is the encrypted content here actually has the authentication tag truncated as well. So it's just XORed with like a stream cipher output. But that is fine because the ciphertext gets put in the additional authenticated data for the sender data. So it all ends up being authenticated the same anyways. It's just all of your authenticated data is sort of unintuitively against this little encrypted sender data piece. Because when you see the sender data, that's always encrypted under the same key. So you start to be able to use the results from this paper and the same quick approach. You just have to flip it around.
Sorry, Brendan, you're saying that you would. So I thought both the proposal on the slide and the ones in the PR, I thought both of those still had an extra auth tag that authenticated the sender data. Am I misremembering that?
Yeah, so there's only one auth tag, and it's against encrypted sender data.
So how is the content authenticated then?
The ciphertext goes into the additional authenticated data for the sender data. So basically the entire MLS ciphertext, except for the sender data, is the authenticated data for the sender data. And that's how you get rid of both the explicit nonce and the unnecessary auth tag. So you only need one auth tag per ciphertext. And I said in the PR that I think that might be like an efficiency concern because you basically have to do two passes over the ciphertext. And the first pass is to authenticate it when you're decrypting the sender data. And the second pass is to actually decrypt it when you actually want the ciphertext because you've authenticated it. I don't think that's going to be a big issue for implementations because the crypto has not historically been our bottleneck. And also if you can optimize, you can probably go from using like an AEAD, like AES-GCM, to like actually just decrypting the ciphertext with AES counter, right? So you don't have to do the unnecessary computation of the auth tag when you're decrypting the ciphertext because you know you're not going to use it.
So you're saying that the primary authentication of the ciphertext would be unauthenticated. So you would use not AAD there. You'd use counter mode or something.
Yeah, essentially.
And then you would authenticate it based on the sender data key.
Exactly.
Right, you would authenticate by providing this AAD into the sender data encryption. Interesting. That that seems probably sound to me, but I'm wary of introducing unauthenticated stuff, unauthenticated encryption operations. So it seems like the only thing you save by thinking of kind of the trade-off knob here. So it seems like if you still did AEAD on the ciphertext, you could still save the explicit nonce by sampling the nonce from the ciphertext in the way it was on the slide. So the additional increment you're talking about doing unauthenticated encryption in the ciphertext, all that would really save you is the additional auth tag.
Right.
And the cost would be this having the authenticated encryption there. So I don't know. I'm not sure how I feel about that trade-off.
Well, the additional auth tag is going to be just as big as the nonce. So basically you're saving twice as much.
Should be bigger than the nonce, in fact.
Maybe, I don't remember right now.
I see Nick is in the queue.
Yeah, just relaying a question from the chat from Dan Harkins. He says, if 2passes isn't producing a bottleneck, then why not use a nonceless AEAD like AES SIV?
Yeah, SIV has come up at a couple of stages in this discussion. I think in general, the feeling was, given that crypto agility being what it is, what that would turn into is really a requirement that this, or a limitation that this protocol could only be used with misuse resistant AEADs like SIV. I don't think there's any, correct me if I'm wrong here, but I don't think there's any nonce-less AEADs. There's only AEADs that tolerate nonce reuse better.
I guess
So I don't know.
Ben Kaduk, my interpretation of Dan's question was more that the SIV mode is like a more robust construction with respect to various sorts of flaws or errors or whatnot. And so the cost of that robustness is that you have to do a second pass. But if we're okay doing a second pass in general, then we might want to consider having the more robust mechanism just in general.
I mean, I have no objection to having SIV as an option here. I think the question is just how much we rely on that, which will go to how much we constrain the protocol.
I think that my objection to SIV wouldn't be the performance side. It would be that there aren't always a lot of good implementations of AES SIV available, like in the open source world. But in the performance aspect, we actually do have two different ciphertexts. So just sort of proposing one doesn't make sense, right? So you're going to do like 4 passes, I guess. Or I'm not sure how to actually deploy that. Or I guess I'm saying it's not clear off the top of my head how you would actually use AES SIV in a productive way in MLS.
looks like we got a couple of options that we're going to have to go through to kind of get a sense from the group whether we think one ASSIV does or does not make sense, whether we can do Brendan's proposal or Richard's proposal, and if there's savings or benefits from doing one of the others. Do we think we got enough information to be able to take that to the list at this point?
Yeah, I think we've got enough information to frame a good question to the list. It seems to me that one of these two options should be viable, whereby I mean, where the two options I mean with the extra auth tag or without. And I think the main question is just whether we want to have a dependency on an unauthenticated encryption algorithm as well as an EAD algorithm. We can frame that question to the list.
The only reason why I'm kind of moving this along is because there's 5 minutes left, and I think we got a couple more slides.
It's only 5 minutes. Yeah, we just have a couple more slides. Yeah, so I think we can put this to the list. But yeah, Brendan, thanks for putting that together. That was a useful, interesting take on this. This was a slide I forgot to present, but like I think it's either this or nothing, something like this, or we should just give up on simplifying standard data encryption. Next slide. Just to flag another couple of issues, buckets of issues for folks. This is a discussion that's really active on the mailing list right now. I think we're starting to converge, I hope. The idea here is we expose group ID, epoch, and content type in the MLS ciphertext now, and that's metadata that would be better to protect. Content type is the easy one. You just move that inside of the encrypted payload, and then the discussion we're having right now is what you do about the group ID and epoch, whether we should continue to expose that somehow, or whether it's safe to do something like either encrypting it or replacing it with something opaque. So please tune into the mailing list discussion for that. In the last bucket of things, this was Britta Hale and Conrad Cobrook posted a PR 336 that I was a bit uncomfortable with it just because it addressed a bunch of different use cases in one thing. And so where we are now is that I've been trying to tease these apart into different use cases and kind of get smaller, more digestible chunks that we could land. So it looks like what we need to get to where they wanted to go is to do some protocol mechanics to add extensions to the commit so that we can negotiate PSKs. And then we can do cool things like have resumption. I've put quotes here by analogy to TLS. What we mean is authenticate when you're joining a new epoch that you were part of a previous epoch of the group. So have some derived PSKs off the key schedule and use those to resume. And then there's some stuff which is probably separate from the PSK stuff about Britta has done some work on how to authenticate that people have the same state of the group, which is kind of similar to some of the short authentication string stuff that was done with ZRTP, and there was a 0.0 draft for TLS for how you use it for TLS authentication. But the idea is you derive a secret that is a commitment to the state of the group, and then you can compare that secret to verify that you've got the state of the group, same state, somehow out of band. So this is still in the kind of issue refinement, and we'll move to the PR stage pretty soon. But this is kind of the last major bucket of changes I see.
So, Richard, the one question I had that I think might be missing that Jonathan brought up in the chat is there was a request to change the inputs to the key schedule that's now being discussed on the CFRG list. So we're trying to figure out if we're going to get a warm and fuzzy from them about making this change.
I'm sorry, which changes?
The changes Chris introduced about unifying the inputs, I think is the way I would describe it, to the key schedule.
The NPRF one.
Yes.
Yeah, they called it NPRF instead of NKDF. Yeah, as we looked at the key schedule in 362, I kind of got things in the right order to do joins. It's actually not clear to me that the NKDF is all that useful, because before, in the old order that was not correct, it looked like you were adding 3 secrets to the key schedule all at once. And now it's more like you add 1 and then you add 2. And so it's less clear that we need a multiple combinator. So I'm kind of inclined to put the NPRF stuff to the side for the moment. We can obviously give the CFRG some time to give feedback. I think that may become useful. I think one of the things in the PSK domain is that we're going to a way to incorporate multiple PSKs in a single epoch. So yeah, that's where I was going, Jonathan. I think when you have multiple PSKs or maybe some additional entropy coming in an epoch, we're going to want a way to combine multiple of those. So that's at the very least a future PR and maybe doable as an extension. So I think that it's a little ways down the road in any case.
Okay, and that brings us to the end of our session. We have 50 minutes, and it's 9:50. For everyone else, the plan, I think what we're going to try to do is continue with the interims. We'll probably take a week or 2 off, but then we're probably going to go right back to 1 every other week to try to see if we can bring this to closure. Does that sound like a plan? Does anyone thinks that that's horrible? Obviously, I will double check all this on the list. But I think that's it, and I would like to thank everyone for participating.
Thank you.